Hi, this is Miss Park. This video is a summary of the ambiguous case of the sine law. So, ambiguous case of the sine law was this investigation that we did together in class with the ribbons. So, just to remind you, when you are given the information that is a side and an angle, or in other words, an angle, a side, and another side, these measurements are fixed and cannot be changed. So the question is, can you make a triangle out of these measurements? So we saw in the investigation that depending on the relationship between the lengths of this triangle, you might be able to make a triangle, or you might not be able to make a triangle, or maybe you can make two triangles. So quick recap: if you have an obtuse angle, there's only one way to draw the triangle. So if the obtuse angle is given and the other side is given, and then you're given the second side, there's only one way to draw this triangle. All right, now notice if that second side here, this where my ribbon is, was shorter than the first side, was shorter than 10, I wouldn't be able to make this triangle. Okay, but as long as A is greater than B, little a is greater than little b, I can meet up with the base. And remember, we're not given the length of this base, so it can be any length we want. So I will be able to make a triangle. In the case of case 2, when the angle is acute and I'm given a piece of ribbon or side A that is longer than side B, I can also meet up with the base because I can extend this base to be as long as I want and eventually make a triangle. And there's no other way to draw this triangle if this is the exact length of my second side. In the case of the yellow one, it was too short. It didn't meet up. So it's not only that A is shorter than B, but A is way too short. You can't make a triangle. And this one over here, A is shorter than B, but it's not too short. It actually does meet up with the base, but you can meet up with the base on this side, or you can also rotate it so that it meets up with the base on this side. So you end up with two triangles. You end up with a obtuse triangle, and also you end up with a acute triangle. So this whole thing that is 30 degrees, 10, and whatever the blue thing is, and the other triangle, which is 30 degrees, 10, and where the blue thing is. Okay, so there's two ways to draw this triangle. And what we talked about in class is that the angle that you get, let's say over here, this acute angle, you could figure that out, say using the sine law like we did in class, but that's just one of the possibilities because that's this triangle. The other possibility is this obtuse angle. And that obtuse angle you would get because this one here and this one here are equal, because these two pieces of ribbon create an isosceles triangle, and if these two are equal, then these two are equal. And so if these two are equal, whatever these two are, this measure of this angle is going to be 180 minus that. So if you know angle B, then this is also the same measure as angle B, and so this one is going to be 180 minus that measure. And so now you have two triangles with all the information, enough information for you to solve for anything else in the triangles. So how does this show up in problems? It shows up with if you ever have sine of the angle that you're looking for. So let's say sine B, and you get a number like, I don't know, 0.75. Okay, something like that. You use your calculator. So this is with the sine law. So let's say you're using the sine law and you're getting a bunch of you're following your steps, and this is where you end up. And now when you want to figure out what B is, you bring your calculator and you go inverse sine of 0.75. So I'm just going to use my calculator. And I go 0.75. And I get about 49 degrees. Okay, and so understanding that when we get to here, if the situation was like case 4, where your triangle had an acute angle, and that second side, so angle, side, side, the second side is shorter than the first side, right? So if it satisfies case 4, that the second side is shorter than the first side, it's possible that you'll have more than one answer. So if you use the calculator and you get something like this and you get an answer, we have to now find the second answer. All right, so the second answer will be this. I'll have a triangle where this one is 49 degrees. I would be able to swing that ribbon, right? Pretend it was a ribbon. I'd be able to swing it, and that's 49, and this is 131. So really, I have two possibilities. I have a triangle that's 131, and I have another triangle here with the 49, and all the other information. And so you can use the sine law, but you would get two possible answers. Okay, two possible answers. And how come that only works, that only happens with the sine law and it didn't happen with SOHCAHTOA, right? Last year, when we got sine B is 0.75, we never had two possible answers, right? That's because with SOHCAHTOA, one of them's a right angle. So if you had this angle as 49, there's nothing else that it could be, because the other possibility is this obtuse one. And you can't have an obtuse angle into here. Okay, so it won't happen with right angle triangles. It'll only happen with triangles that are oblique or not right angle triangles. Sorry, triangles that are not right angle triangles. That could happen. That you have an acute answer and an obtuse answer. And let me just try one more thing. Why does this happen for sine? Okay, so you know that in a triangle, angles in a triangle are between 0 and, I'm not going to put less than or equal to, they're between 0 and 180 degrees, all angles in the triangle must be between 0 and 180 degrees. So if I say to you sine B is 0.75, we know from this unit, from cast, right, from angles around the circle, that there's going to be two quadrants where sine is positive, right? There's two quadrants. Sine is positive in Q1 and Q2. So I'm going to have a Q1 answer that looks like this, where this is angle B. And I'm going to have a Q2 answer that looks like this, where this is the related angle, right? But what's the measure of the angle in standard position for quadrant 2 is it's going to be 180 minus B, right? The related angle is equal to B, it's over here. And so the angle in standard position is 180 minus what's over here. So two answers, remember, like we just finished all this. If somebody tells you sine B is 0.75, you have two answers. And that's the explanation of why you have this ambiguous situation. We're given the information, but we don't know if it's this triangle or this triangle. Okay, so the key with the ambiguous case is to understand the four cases. These are the four possibilities that you could have. If you're able to if you're obtuse, you have one possibility. If you're acute and the other side is longer, you have one possibility. These two are not ambiguous, right? Remember, word ambiguous, it means it's uncertain or unclear. These are not unclear, okay? This one also is not unclear. This side is too short, all right? And how do you know something's too short and the triangle is not possible? Because if you use the sine law on this, you would get a value for sine that is impossible. If you go inverse sine with your calculator, you'll get an error. This triangle is not possible, so you will have an error from the calculator. But in this case, if the angle is acute and the second side is shorter than the first side, and you do get an answer from the calculator, then you know there's two answers. This is the ambiguous case right here. This one here. Because we have the same information, but because of the relationships between the sides, it's ambiguous. We don't know if it's this one or this one. So when answering questions, it's both. I'm going to give two answers. All right, hope that makes sense. Please try to do the practice. Thank you. Thanks for watching.